All right, in this video, we're going to talk about line segments and distance. A line segment we talked about in notes 1.1 is part of a line. It has a beginning and an end, so you can find the distance of a line segment where you can't find the distance of a line because a line goes on forever. Okay? We have congruent segments. The word congruent is going to come up a lot in geometry. So congruent means they have equal length, okay? So equal measurements. So if two line segments are congruent, that means that they measure the same thing. So 5 centimeters, 5 centimeters. Okay, the betweenness of points is the distance between 2 points on a number line, and it's the absolute value of the difference between the two coordinates. So we're going to have an example here soon where if I have a number line, for example, like -2, -1, 0, 1, 2. Even though I have some negative numbers in here, I'm going to count like the distance between this one and this one is going to be the absolute value. So it's not like I'm adding -2 plus 2 to give me 0. Instead, what's happening is I'm counting the physical distance between 2 points, even if it is negative, and having an absolute value answer. So the distance between -2 and +2 would be 4. Okay, then we have distance between 2 points using the number line. So very similar to the one I just showed you there, you are going to take the absolute value. So that's why you see these absolute value here. Okay, and you can go positive number minus negative number. It doesn't matter if you do x2 minus x1 or x1 minus x2. Because you have that absolute value, we're going to get the same answer. And the last way to find the distance between 2 points is by using the distance formula. You have seen this distance formula before. It is something you should memorize. Something that helps when you are given 2 points. So let's say I had the point like 2, 5 and the point 10, 17. It really does help if you go through and label the points. This should be a 1 here in the notes. So I would label this one x1, y1, x2, y2 before you start substituting the values into the formula. That way you don't get mixed up, okay? So it is easier if you go ahead and label from the beginning. So let's jump right into the example. So find the measurement of each segment. Assume each figure is not drawn to scale. So the reason why it says not drawn to scale is because sometimes the picture will make it look like one part of a segment is longer than the other, but you always want to go based on the numbers that you see, okay? So I want to know the distance of RT. So I'm going to highlight where RT is, and in our case, that's the whole thing, okay? So I need to take this piece, 2.0, and I'm going to add it to this piece. That's how I'm going to get the entire thing, okay? So here's where you can use a calculator if you'd like. 2.0 plus 2.5 comes out to 4.5, and these are centimeters. So I am going to label those units. Okay. All right, for number 2, I want to know the value of WX. So WX is just this first piece right there. And this picture has some important information that we need to talk about, like what this means. So these 2 marks here, that's how we label in geometry that these 2 pieces are congruent. So because these 2 pieces have the same markings, both of them have like those 2 little lines, it means that this half has the same measurement as this half. So if the whole thing is 6 centimeters and I only care for half of it, I'm going to take 6 divided by 2, which gives me the measurement of this half. So this here, this half is 3 centimeters, and this one's also 3 centimeters. I know they're equal because of these markings, and together they make up the 6 centimeter segment. Okay, number 3 here. So for number 3, I want BC, so this right there. Okay, so the whole thing is 6 inches, and I don't care about just this portion. 2 3/4. Okay. So if you're using a calculator, you can just type it in. If you like to convert this to decimal, it can be 2.75, however you want to do it. But you go ahead and just subtract, and we get 3 1/4 or 3.25 if you made that a decimal, and these are inches. So for these examples, it helps to highlight or underline exactly what you're talking about or which measurement you want to find, because that can mean you're going to add two things together. It could mean you're going to subtract the two pieces from each other. So if you highlight it or underline it, it will help you figure out what you're supposed to be doing. Okay, and this last one here, xz is the whole thing. So when it's the whole thing, two pieces make up that whole thing. That means I'm going to add them. So I have 3.5 plus 3/4. And again, this helps if you're using a calculator. You guys are more than welcome to use your phone calculator for this. If you turn it into a decimal, that works too. And it comes out to 4 1/4 or 4.25 if you made it a decimal. All right. For 5 and 6, we have the same instructions. Find the value of x and RS if S is between R and T. So the first thing we want to do is draw a picture, because there's a lot going on in that problem. So I know that S is between R and T. So it doesn't matter how you draw this, because at the beginning we said the pictures were not drawn to scale, but I have R here and I have T here, and S is between them. So now we're going to label the different pieces. So this part says that RS is 5x, so I'm going to go ahead and label 5x from here to here. ST is 3x, so this portion right here. And RT, the entire thing, is 48. So this is what's called the segment addition postulate. It says that if I add up the two pieces, so 5x and 3x, together those two pieces should also equal 48. And then from here, it's just solving for x, so that's what the problem is asking us, to find the value of x. So 5x plus 3x is 8x. Divide both sides by 8, so x comes out to be 6. The problem is also asking us to find RS, so we need to go back and substitute with the new value of x. Because RS is equal to 5x, I'm going to replace my x with 6. So RS is 30. So you need to be careful and make sure you're reading the full question. Make sure that if it's asking you for x and the segment, then you answer both parts. Okay. I'm going to draw the same picture over here for number 6. So RT and S being between them. So here's R, T, and S is between. This time RS is 2x and ST is 5x plus 4. The whole thing is going to be 32. So go ahead and try this one. Go ahead and pause the video right now and then come back to see if you got it right. So the equation you should have set up is 2x plus 5x plus 4 equals 32. So both of these segments together should equal the whole thing. I'm going to combine like terms. My x's give me 7x, and this is plus 4 equals 32. Going to subtract 4 from both sides. That gives me 7x equals 28. And lastly, I'm going to divide by 7, giving me x equals 4. Same thing, it's the same instruction, so I have to go back and find RS. So I'm going to substitute my x value here. 2 times 4 gives me 8. All right, next set of questions. Determine whether each pair of segments is congruent, okay? So it's asking here, A, B, and CD. Are A, B, and CD congruent? Do they have the same measurement? Okay, so here I'm looking at these sides of the parallelogram. They both say 5 centimeters. So the answer here would be yes. And you can just look at this picture and see that the sides are congruent because they have the same measurement of 5 centimeters. On this end, we have XY, so this side, and YZ, this one. So for this one, we have to do a little bit more work, okay? We can't just look at this one and determine whether it is congruent or not. But we can do a little bit of math based on the markings in this picture. So I know if it has these two markings, I can set those sides equal to each other because those markings mean that these are congruent. But I'm not asking about XZ, I'm asking about YZ. So first I need to solve for X here. I'm going to add 1 to both sides and I'm going to subtract 3x from both sides. When I do that, I'm going to end up with 6 equals 2x. Divide by 2, and x equals 3. Okay, well, if I substitute 3 for x over here, I get 3 times 3 plus 5, and that gives me 14. If I substitute 3 over here, so 9 times 3 over 2, 9 times 3 is 27, 27 divided by 2 is 13.5. 14 and 13.5, these would be the measurements of these segments once I substitute in the x value. Therefore, they are not the same. They are not congruent after I solved for x. So this one, like I said, is a little bit more work, but once you go through and figure out x, you can go back and substitute and determine if these two measurements are congruent. All right, for number 9, we're using this number line to find QR. So first thing I want to do is identify where QR is. And because it's in the number line, I have 2 ways to do this. The easiest way here is to literally just count how many jumps it would take you to go from Q to R. So 1, 2, 3. Okay, so QR equals 3. Mathematically, the way I would do this, I would start off by saying, okay, my start point is -3, and I'm going to the left, so minus -6. And in math, 2 negatives mean 1 positive, so -3 plus 6 is also 3. So whichever way you want to think about it, mathematically you can do the math this way, or you can just count how many spaces it takes you to get there. So I'm going to give you a moment here to try to figure out what number 10 is, BG. So go ahead and pause now and see if you can figure it out. All right, so identifying BG is this entire thing. You can go ahead and count, see how many hops it takes you to get there, or you can do it the mathematical way. You start at 8 and then subtract, go left, -7. This is at -7 right there, between -6 and -8. When I do that, it gives me 15. So hopefully you have BG equals 15. Okay, so that's how you find the distance with a number line. Like I said, I think the easiest way to do it is just to count how many number spaces are between the 2 letters that you are trying to find. Then we have finding the distance between 2 points. So when we're given 2 points and no number line, we want to go ahead and use the distance formula. And the distance formula is on the first page of these notes. Okay. And remember I said that you may want to label your points first. So this is your x1, y1, x2, y2. And the distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. Then once I label the points and which one's x1, y1, and so forth, then it makes it a little bit easier to go ahead and substitute. Okay, so I'm going to keep going here. Keep the square root the same. So x2 minus x1. So identify which one's x2. That one's going to go first. For me, the x2 is 3 minus, and then x1 is negative 4. You have to make sure and be careful here. The minus is part of the equation, and even though x1 also has a minus, we have to go ahead and keep both. Then we have the plus sign as part of the formula. y2, for me, y2 is negative 1 minus y1 is 1 as well. And then we square that. Okay, so from here you can use your calculator or you can just do the math in your head. This becomes a big plus, two negatives next to each other. So 3 plus 4 is 7. 7 squared is 49 plus. We have negative 1 minus 1 is negative 2. Negative 2 squared is 4. So then I'm going to go ahead and get square root of 53 here, and I'm just going to leave it like that. I'm not going to simplify or anything at this time. Okay. All right, so number 12 is the same thing. So go ahead and pause the video now so that you can go ahead and try it. All right, hopefully here's what you did. I'm going to label this x1, y1, x2, y2, distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so for me again, the x2 in this case is negative 3 minus x1 is a positive 7, then I'm going to square that. The y2 in my case here is negative 8 minus the y1 is positive 8 squared. All right, so here I get negative 3 minus minus 7 is going to give me a negative 10. Negative 10, so if you go off to the side, squared gives me 100. So this becomes 100 here. This negative 8 minus 8 is negative 16. Negative 16 squared is going to give me 256. So I go ahead and add those two up. I get 356, and I'm just going to leave it here. Now you can go ahead and plug this into your calculator and get a decimal answer. In this case, it would be 18.9. We are later going to go over how to simplify radicals, so if you leave it as a radical and stop there to avoid error, that is totally fine. All right, last two problems here. We have some word problems, so let's look at number 13. A straight railroad track is being built to connect two cities. The measured distance of the track between two cities is 160.5 miles. A mail stop is 28.5 miles from the first city. How far is the mail stop from the second city? Draw a picture to demonstrate your thinking. Okay, so we have two cities here. Just city 1 and city 2. And we have something being built between both cities, so a mail stop. Now, from the first city, it says that it's 28.5 miles from the first one. So I'm going to go ahead and create the mail stop here. And this is going to be 28.5. And that's miles, if you want to go ahead and label that. Then I have to figure out essentially how long this section is. Okay, so what other piece of information do I have? The distance between the two cities is 160. So this entire thing is 160.5 miles. So essentially I need to find the difference between the two. Okay, so I have 160.5 minus 28.5. So I'm going to go ahead and give you a moment there to do that math. And hopefully you end up with 132.0. So this is how many miles are between the mail stop and the second city. All right, the last problem we have here says, a hiking trail is 20 kilometers long. Park organizers want to build 5 rest stops for hikers, with 1 on each end of the trail and the other 3 spaced out evenly. Okay, so I have the trail, and this is my first stop, this is my last stop, and I want 3 more spaced out evenly. So like 1, 2, 3, right? So stop 2, stop 3, stop 4. So the entire thing is 20 kilometers long. I have to figure out the distance of each individual segment. So the reason why I'm coloring it differently here is, yes, you have 5 stops total, but you want to know, essentially pretend this was a number line, how many hops it would take you to get from one to the next. Okay, so that's 4. So I need to take the 20 kilometers and divide it by 4 to figure out how much distance is between each stop. And that's the end of our notes.